7.6 Common Logarithms. Common logarithms are written like this, just the log of a. You'll notice there isn't any base here, and when there isn't a base, there's always an invisible 10. Our number system is a base 10 number system. So when we're asked to find a log of a number without any base, it's just implied that it's a base 10 log. On our calculator, there's a function that'll find these logs for us. If you're using the TI-34 multi-view, it's right here. You can see log right above that PRB button. So it's second first, then that PRB button. If you're not using this calculator, look for a button or an option that says log. If you can't find it, sometimes you'll have a math button with a bunch of different functions in it. So click that math button and see if it's in there. If we're asked to find log base 7, we're just going to hit the second key. We're going to hit this log button. We're going to put in a 7, hit enter. We get 0.845. Same thing with log of 0.5. We get negative 0.301. So what is this really telling us? It's telling us that if we took 10 and we raised it to this exponent 0.845, it's going to give us a 7. If we took 10 and we raised it to a negative 0.301, this is going to go to the bottom of the fraction and turn it to a positive 0.301 there. Okay, that's going to give us a 2 on the bottom, turns into 1/2, gives us a 0.5. Now the reason we need to know logs is because it helps us solve equations where the x is one of the exponents. 4 to the x power equals 19. We want to get this x out of the exponents into the regular body of the equation so we can solve it. If this were a log, we can move it out front like this. So this is what we're going to do. We're going to take the log of both of these sides of the equation. Log of 4 to the x power equals log of 19. When we do that, we can take that x and move it out here. So now we have x times log of 4 equals log of 19. Divide by log of 4 on both sides. And we get our answer, 2.124. Same thing with this next one. Take the log of both sides here because this x is in the exponents. When we do that, we can take that x, using those logarithm rules, move it out front. X times log of 3 equals log of 15. Divide x equals 2.465. This we're just plugging right into our calculator. Make sure you close the parentheses. That's a common mistake I see students make. We can also use base 10 logs to help us find other log bases. For example, log base 3 of 7. Rewrite it, log base 7 over log base 3, plug it into our calculator, we get 1.771. That's the same thing you would get if your calculator has an option to put in a base that's something different than a base 10 log. Log base 6 of 8, log of 8 on the top, log of 6 on the bottom, 1.161.